From the sun, the moon and flames to ultra-modern semiconductors, human history is inherently bound to light. In this program, we meet scientists and engineers who are making our futures brighter. The sunlight brings us comfort and safety. Wherever we are, we need to see the sky. It's in our nature. Rooms with no windows make us feel bad. But there are no windows in this radiosurgery unit in Milan. And outside, it's raining. What you see is a stunning, realistic illusion of sunlight. Notice how different the room looks without it.
This is an enclosed, protected space because of the radiation, and that can make the patients feel claustrophobic. This window creates an extremely realistic feeling of light, exactly like a real window, and that makes you feel better, calmer when you enter the room.
Here is the optical system that hides behind the window. Right now it's rather big and costs about the same as an average car. A result of a European research project, it consumes just 300 watts of energy and has already won several industry awards.
How do we make a virtual window? This device is based on an LED projector that has all the spectral characteristics of sunlight and creates a narrow beam with realistic shadows. Inside this device are all the optical systems that allow the observer to perceive the image of the sky with the infinitely distant sun. Within our project, we're aiming to develop a sufficiently compact device that can be installed not just at home or in a hospital room, but even in a lift, a car, a ship's cabin, a train, a plane, anywhere at all.
Artists know that the sun creates certain optical effects on surfaces. If we want the light to look natural, these effects need to be understood and reproduced. But how do we get the right color? Professor Paolo Di Trapani has managed to recreate the exact atmospheric process that makes our sky blue.
The atmosphere contains air molecules that move, creating fluctuations in density at an extremely small scale of nanometers, a millionth of a millimeter. We're reconstructing these fluctuations using nanoparticles, a highly concentrated dispersion of tiny spheres with a slightly higher index of refraction than that of water. Let's pour them in the water.
The blue part of the spectrum scatters, turning the water sky blue. The reddish yellow passes through. That's the reason why we see our white sun as yellow when looking through the atmosphere. The same principle works in the window device with the nanoparticles fixed in transparent plastic instead of water.
Our technology isn't artificial lighting, it's a window that recreates the infinite space which man has been used to for hundreds of thousands of years.
The inventors see this as a new philosophy in indoor lighting. Unlike lamps that create spots of light that remind us of surrounding darkness, these windows create a sunlit world outside, a world that can be turned off with the flick of a switch. Inorganic LEDs have many advantages, most notably they're bright and efficient, but the organic light-emitting diodes, OLEDs, have rather unique qualities that open up completely new possibilities. We're in Eindhoven, where industrial designers meet material scientists. They're exchanging ideas on how to use flexible electronic components, including OLEDs, in new products.
You can actually approach the problem from two sides. The material scientists tend to work bottom-up, from the physics to the mechanics to how it works. The designers, they tend to think from the outside in, from why this would make sense for a user. Why someone would enjoy using it.
child healthcare is one of the areas where smart, flexible electronics can be particularly useful. The lights in this tablecloth can interact with plates, adding magic to hospital meals.
We have been focusing on hospitalized kids and we have been asking doctors what is the biggest problem with recovering for a child when they are hospitalized. For instance, we've been talking to cancer departments and one of the biggest issues is lack of appetite, and that is really important to eat when you want to recover. So the idea was to work with this eating situation and try to bring magic into that.
What's applied here is the traditional technique of embroidery, as we've known for millennia, in order to carry current from one point to another.
Here's another example. This toy bracelet appears to come alive when touched and cared for, an attractive way to distract a child from unpleasant medical procedures.
Light is the primary output that kid can see something is happening when they interact with it. So you stroke it, you feel it's buzzing, but you also see that it lights up. It's a very powerful behavior, light. It's very easy to understand.
Adults may appreciate a prototype glove that helps recovering patients to train an injured hand. Its flexible lights visually assist with the exercise.
This largest light piece gives feedback on the correct or wrong execution of the exercise, and the pieces on the fingers light up when they're bent.
Unlike LEDs that create small dots of bright light, organic light-emitting diodes function as beautiful glowing surfaces. The problem is large OLEDs produced in vacuum evaporators are difficult to make and very expensive. But these European researchers are developing a new technology to print OLEDs in rolls, potentially making light sources as large and as flexible as wallpaper.
This is really flexible, yeah. And over the next years, you can see we can bend this over certain radii. Our idea is to make it really crumbable. So we can make like a towel, we can wrap it, put it in your pocket, unfold it, and you have your light source. Instead of making it with a complicated process, we try to make it with a kind of printing. So we are trying to make OLEDs like printing a newspaper.
This prototype line uses silver paint to print electric circuits on transparent polymer film. To accelerate the process, the machine dries the wet paint with flashing lights.
When I touch here, I smudge it. So we use this machine here, which heats the silver with light pulses for a short time at high temperature.
Das Silber wird auf die Weise erwärmt für sehr kurze Zeit zu hohen Temperaturen. Und dann, wenn ich dann hier
And now if I touch it, it's dry.
Dann ist das Ganze also trocken.
This can become the base layer for a large surface OLED. It would need several more layers of various chemicals to produce light. It's research that's continuing. New light technologies give us better comfort and create fantastic possibilities for consumer electronics of tomorrow. But the perspectives are much wider, even in the most traditional fields. For instance, how safe are agricultural products? A new instrument sheds some light on that problem. The Veneto region in Italy is famous for its wine and cheese. This company has been producing mozzarella and other products since the 19th century. The cheese is packed with a specific mixture of atmospheric gases that protects the food from spoiling.
Abbiamo dei parametri che noi li dobbiamo rispettare.
There are certain parameters that we must respect, and one of them is the oxygen level that should be less than 5%. Today we're checking for that, manually, checking some of the packages in the lab.
A random sample is pierced with a needle. The probe shows the oxygen level, but now the product has to be repacked. Is there a better way? Yes, and there's already a working prototype.
The bag arriving on a transporter belt enters the measuring device and has to go through a laser that measures the oxygen level in the package. The light passes through the bag, interfering with the oxygen molecules inside, and that gives us an indication of the oxygen level in a completely non-destructive, contactless, purely optical way.
This works with any non-metallic container. The low-power laser doesn't damage the packaging and keeps the food intact. This allows inspection of all of the products, not just a random sample.
To differentiate one gas from another, we illuminate it with laser light at a wavelength that is only absorbed by a certain gas. By measuring how much the light is absorbed, we find the concentration and the pressure of this specific type of gas inside the container.
These laser probes are now being tested at 2 food factories. Researchers say the major food manufacturers have shown interest in the technology.
I'm sure the industry will appreciate this technology that allows the control of 100% of products, providing much greater food security.
From the comfort of a man-made sun to improved health and safety, bright ideas of European researchers are giving us a glimpse of our future in a new light.